Okay, I wanted to show how to locate this pure sine wave inverter using the 4047 from Homemade Circuits just for you. Designed by Swagatam Majumdar. You can Google on pure sine wave inverter circuit using IC 4047. That'd be the title of the article. It should come up. And this is the page where it's at. His blog website is Homemade Circuit Designs just for you. And this would be the pure sine wave inverter circuit using the integrated circuit 4047. He discusses basically the thought process of designing it, and you see where some of his readers have built it on a breadboard. Here's a breadboard picture by Mr. Aaron Dev. He's one of the readers of the blog, and he has some pictures of close-up pictures of it in action. Over here is a little bit of about me section about Swagatam. It says he also runs a Homemade Circuits and Schematics blog spot. So he's got a couple going. He's got plenty of articles, tons of circuits in here. Here's another build with the light bulb going again. And here is a oscilloscope from Mr. Daniel Doozy. Pardon my pronunciation, if that's not how it's pronounced. And he's showing more of a sawtooth there in his testing building. Eventually he gets it closer to a sine wave. More like a modified sine wave here. So Swagatam suggests some modifications here in another circuit diagram. And basically this one here is showing the addition of a BC547 transistor, and that's to enable PWM across more than one MOSFET. Here's a picture from Mr. Isaac Johnson, who has it running, looks like on a breadboard there with a fluorescent light here. Isaac Johnson is saying it's nice to see a fluorescent lamp to light up with this sine wave inverter, because it's he writes that it's a little bit difficult to get fluorescent lights to turn on with the usual modified sine wave type of inverter. He's got a nice display there, and he's got a big comment section here. A lot of comments about discussion about how to build it, parts, things like that of that nature. So basically we're looking at his latest design here, last design here for that, and that'd be this picture here. Here's a close-up view of it, where he has an NE555, 7555, 7555, and a 4047 here. I've added a few notes on, for example, I added a note about the D1 Zener here. It's got what is a European format, I believe, for the symbol, but over here on the left it's got another Zener with the US design symbol for that. I wanted to show if you're going to extend more than two MOSFETs, that's the way I have my setup going. 100 ohm resistor to each MOSFET, and that feeds to the transformer. I want to spend some time, it's about my 5 or 6 build on this thing. I spent some time looking at the waveform. What you want is a sine wave like this. This picture is captured from using a 0.047 microfarad capacitor at 60 hertz, 4 FETs, and 100K for the P1 resistor. I also have another one. This is using a 0.22 microfarad capacitor at 60 hertz and 4 FETs, 100K P1. Typically, if you don't do much monitoring of the sine wave with the oscilloscope, you'll see these spikes occurring. This is using a 0.1 microfarad capacitor at 120 hertz. Excuse me, at 53 hertz here on 4 FETs. And here's another one where I've got a level 3 filter on the end just before the transformer. That's using 0.1 microfarad. I'm running here at 75 hertz and just the default 2 FETs with 55K at P1. Again, that's with the level 3 filter. So I spent a lot of time trying to adjust the spikes that you might see, and I believe that's due to the PWM. You probably don't even need to worry about the spikes because it is PWM. You gotta notice that the height of the spikes change over time. That's but normally you'd expect that to fall within the sine wave. But if you trace out the height of the spikes, it traces out a kind of like a sine wave pattern there just from the PWM. PWM is meant for control over the frequency when you add more than when you have a variable load. Try to add devices with different wattages or more than one device. So automatic, it's supposed to be automatically compensate for that varying load. So that's basically it. I wanted to show you this web page where you can find the circuit, what I'm working on here. Homemade circuit designs just for you from Mr. Swagatam. And this article is, once again, pure sine wave inverter circuit using a IC4047.